Hello, welcome back to Statistics and Mathematics YouTube channel. Today I'm going to start as we are going to continue from the series of video on statistical method 1 that we started earlier. Then we are going to consider a subtopic called mutually exclusive events and then addition rule. Before one can really understand addition rule, one has to appreciate what is termed as what mutually exclusive event. So what is mutually exclusive event? Mutually exclusive event, we say that two events are mutually exclusive if they cannot occur at the same time, right? If these two events cannot occur at the same time, it is just termed as what mutually exclusive events, right? Let's assume two events A and then B, right? So if A and then B does not occur together, then we are trying to say that the event is what mutually exclusive. So if the event is mutually exclusive, it means that probability of A intersect probability of A intersect B is equal to what? 0. It means that they do not have anything in common. So it can be represented by what we have here, the Venn diagram that we have. The first circle represents what probability for A, so the second circle represents probability for what B. And you can see clearly that there is no intersection between what the probability of A and the probability of B. So here the probability of A and the probability of B are mutually exclusive event. When we come to the second diagram, we have the first circle to probability of A, second circle being probability of B, right? And these are non-mutually exclusive events because they have something in common, right? So the probability of A intersects with what probability of B. So here they are not mutually exclusive events. So when we say mutually exclusive events, they are events that cannot occur at the same time. That is what mutually exclusive event. So once you have been able to appreciate the mutually exclusive event, then let's come down to the addition rule, right? The probability that two events A or B will occur is, so for this one, the probability of A or B being occur can be written as probability of A union B, which can be further be expressed as probability of A plus probability of B minus probability of A intersect B, right? But if the events A and B are mutually exclusive, then probability of A union B can be written as probability of A plus probability of B, because probability of A intersect probability of B will be equal to 0 once the event is mutually exclusive, right? So once you have been able to appreciate this one, let's get ourselves into solving a problem for us to really appreciate how we can apply these formulas, right? So here the first example, it said you roll a die, find the probability of obtaining a number less than 3 or an odd number, right? We know that when you roll a die, the sample space is what? 1, 2, 3, 4, 5, 6, right? And then it said you find the probability of obtaining number less than 3. So let's say you make A, right? Make A represent number less than 3, and let B represent odd number, right, from the event, right? So here if A is what? Number less than 3, then we can see clearly that if there is a sample space and the number is less than 3, that is, we are going to have 1 and then 2. And then if you haven't this and then we are told of getting an odd number, I mean, we are just going to look through the sample space to select what the odd numbers from the sample space. And we know that odd numbers are numbers that are not divisible by 2. So here we have 1, 3, and then 5 to be what? Our odd numbers for the B, right? And then we could see clearly that though the question didn't tell us or give any information that the event for the less than 3 and then an odd number is what? Mutually exclusive, or they are not mutually exclusive. We can see clearly from the list that A is having something in common with what? B. Well, there is an element 1 here that is appearing what element that is appearing what? B2, right? So here A intersect B is also giving us a set of what? 1, right? So right now we have been able to get the element for probability of element for A, B, and C, A, B, and probability of A intersect what? B. So let's get the probability for the expression to be very simple, right? So probability of A is equal to number of A divided by what? Number of the sample space. And we know that number of A is what? We are just going to count the element we have in element A, right? That is 2. And the sample space, we count everything here and we are getting what? 6, right? So that's probability for A. What about probability for B? Probability of B2 is number of B divided by what? Number of what? X, right? Of which we are getting, we are just counting the number in B. The number in B is what? 3, and the sample space is 6, right? So right now we have probability of B, probability of A. What are probability of A intersects B? We have only one element here, so here will give us 1 divided by what? 6, right? So right now we have been able to calculate for the probability, and we know that probability of obtaining a number less than 3 or an odd number can be expressed as probability of A or B can be expressed as probability of A plus probability of B minus probability of A intersect what? B. And then once we give this expression, this will be our final answer, 2 divided by what? 3. Let's go to our next question. A blood bank catalogs the types of blood given by donors during the last 5 days, right? So here we have blood group O, blood group A, blood group B, blood group what? AB. Then we have RH plus and then RH minus, right? So this is the total for the blood group O, which is 184. The total for blood group A, which is 164. The total for B, which is 45. The total for AB, which is what? 16, right? And then the total for RH plus is what? 344. The total for RH minus is what? 65, right? So when you add this one, you're getting 409. When you add this one, you're getting what? 409. So here our sample space for this question is what? 409, right? Before we can solve this question, right, we have to get our probabilities what? Down, right? Probability for blood group O, probability for blood group O is equal to what? Number of O divided by what? Number of what? Sample space. Number of O is what? 184. 184 divided by what? Number of S is 409, right? So what about blood group A, right? Number of what? A divided by what? Number of X, which can be given as 164 divided by what? 409, of which our number of A will be this. Our number of B will be given as what? 45 divided by what? 409. That's 45 divided by that. And then our number of what? AB can be given as what? 16 divided by 409, right? So right now we have probability for blood group O, probability for blood group A, B, and what? AB. What about probability for RH plus? Probability for RH plus, you see, is the number of what? RH plus divided by what? The sample space, of which our number of RA plus is what? 344 divided by 409. And then probability for RH minus is equal to 600, and that's number of what? RH minus divided by what? Number of what? X, which is giving us 605 divided by what? 409, right? 409. So right now we have our probability for all of them, right? And then we have been asked to find the probability that the donor has type O or type B blood, right? So here we are letting O represent the blood group O and then A represent blood group A. So we are having probability of what? Blood group O or probability of blood group A, which is given as probability of O union probability of what? A, right? Probability of O union probability of what? A. So for this one, this is equal to probability of what? O plus what? Probability of what? A. You see, these two events are mutually what? Exclusive. Why? Because we are talking about blood group O and blood group A, and there is no way blood group O and blood group A is having something in common. So definitely these two events are mutually what? Exclusive. Even if they haven't told us that the event O or A are mutually exclusive, we can see it clearly from the table that they are what? Mutually exclusive. So let's go to the solution sheet to continue from there. So this is how it can be written. And right now we have our blood group O to 184 divided by 409 plus our blood group A to 164 divided by 409. Once we add everything, we are getting 348 divided by 409, right? Yes. And for let me clean this so that I'll get space to explain this one to you. So for the blood group B, or blood group B, type B, or Rh negative, right? So this one you are getting probability of what? B or probability of B or Rh negative. This can be written as probability of what? B plus probability of what? Rh minus probability of what? B intersects Rh negative, right? So here these events are not mutually exclusive. Why? Because you could see that someone is having type B and at the same time belonging to what? Rh negative. So when we come here for blood group B, right, we are having someone who we are having 8 people under blood group B who are what? Rh negative, right? So definitely this cannot be a mutually exclusive event because the probability of B intersect Rh negative is what? 8, right? So this can be further be expressed as probability of B or Rh negative can be expressed as probability of B plus probability of Rh negative minus probability of B and Rh what? Negative. And we know that probability of B is 45 divided by 409 plus this one is also given as 65 divided by 409 minus 8 divided by 409. But let me show you how we find the 8. You see, we are having blood group O and then 8 people, sorry, blood group B, and the 8 people are under blood group B who are for Rh negative. So here our number of events will be 8 and number of sample space is 409. That's the reason we are getting 8 divided by 409. When you add and subtract everything, we are getting 102 divided by 409. Right? Let's go to our third example. We said at a political relay there are 20 Republicans, 13 Democrats, and 6 independents. If a person is selected at random, find the probability that he or she is either a Democrat or independent. Right? So right now we are to find probability of what? Democrat or what? Independent, which is being written here. Probability of Democrat or independent is given as probability of D plus probability of what? I. So here the events are what? Mutually exclusive because they are two independent parties standing on themselves. So we could see that it's highly that someone will belong to a Democrat and also belong to an independent, right? So here they are mutually what? Exclusive, right? So how can we calculate for probability of what? D and probability of what? I. Right now we know our sample. Sorry, we know our number of samples to be 20 plus 13 plus 12 because 20 is for the number of our Republican, 13 is for the number of our Democrat, and then 6 is for the number of what? Independent. So when we add everything, you are getting what? 39, right? So since you are having 39, probability of D, that's we are letting the D represent what? The Democrat. So probability of D, that's the Democrat, will be number of D divided by what? The number of sample space. And the number of D is what? 13. Right? You're having 13 Democrats. So here we are having 13 divided by what? 39. Right? And the probability of I. Probability of I, we are having what? Independent, right? So we are having probability of I to be equal to number of what? I divided by what? Number of the sample space. The number of I is 6. So 6 divided by what? 39. And then for the R, we are having 20 divided by what? 39. So since we are having probability of D or I, this is how it can be expressed. And then our probability of D is 13 divided by 39 plus for the I is 6 divided by 39. When you add everything, you are having 90 divided by 39, right? Yes. And then let's go to our last question. So for our last question, we are saying that in a hospital unit, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are females. If a staff person is selected, find the probability that the subject is a nurse or a male, right? So here, this is an addition rule. Was you are asked to find probability of subject being a nurse or a male. So here what you are going to do is to use N. We want our N to represent what? Nurse. We want our M to represent what? Male. We want our F to represent what? Female. And then we want our P to represent what? Physician. Right? So here we are told to find probability probability that the subject is a nurse or a male, right? A nurse or a male. So this is how it can be written, right? And then we could see clearly, before we continue, I want us to represent this one on a table for us to really appreciate what is actually going on. So we see in a hospital unit, there is 8 nurses and 5 physicians. 7 nurses and 3 physicians are females, right? So the total of nurses are 8, the total of physicians are 5, and then out of the 8, 7 are females. Out of the 5, 3 are females, right? So let's indicate this on a diagram for us really, a table for us to really understand, right? So here we'll be getting our nurses and we'll be getting male and females, right? So for the nurses, we are having 7 to be females, and having 3 to be physicians, right? And then for the males, we are having 1 to be nurse, and then 2 to be physician, right? So when you add the female, you are getting 10. When you add the male, you are getting 3. So when you add the number of nurses, you are getting 8. When you add the number of physicians, you are getting 5. And the total, that's the sample space, is 13, right? So right now we have probability of n or m, which will be given as probability of n plus probability of m minus probability of n and m, right? This is not a mutually exclusive event because there is a nurse who is a male, right? So the nurse who is a male is 3. So there is an intersection, right? So here we will have probability of n. Probability of n will be 8 divided by 13, right? Plus probability of m, that's the male, which will be 3 divided by 13, minus probability of n and m, which is 1 divided by 13. When you add and subtract, you are getting 10 divided by 30. So this is Statistics and Mathematics YouTube channel. If you haven't subscribed, kindly subscribe, like, and share so that this video will get to your friends for them to also be blessed. So this is a test I'm leaving you guys with. Kindly solve and share your solution at the comment section, and I'm surely going to approve the answers for you. Bye, and have a great day.